Good morning, all of you. Myself, KVS Murthy, working as Assistant Professor in CSE Department, SRKR Engineering College, Bhimavaram. Course Cryptography and Network Security. And today I will explain about block cipher modes of operations. The major objective of this lecture are to understand the block cipher modes. We know that a DES algorithm encrypts a 64-bit plaintext into a 64-bit ciphertext. While encrypting the message of length larger than 64 bits, we use the following block cipher modes: ECB, electronic codebook; CBC, cipher block chaining mode; CFB, cipher feedback mode; OFB, output feedback mode; and counter mode. And this now this is the electronic codebook. Now this is the electronic codebook. Initially the message is divided into 64-bit blocks. If necessary, the last block is padded on the right hand side with zeros to get exactly 64 bits in each block. In the diagram, we observe that M1, M2 and so on Mn are the plaintext blocks, each of length 64 bits. Now each block is encrypted separately with a key. We will get a ciphertext block for each plaintext block. All these cipher blocks are combined to get the ciphertext of the given message. We have to note that we use the same algorithm and key for each encryption. The following are the expressions for ECB encryptions. C1 equal to EK of M1, C2 equal to EK of M2 and so on, and finally Cn equal to EK of Mn. Now we have to combine all these C1, C2 and so on C1 ciphertext blocks to get the ciphertext C for the original message M. And this diagram shows ECB decryption process. Here after receiving the and this diagram shows the ECB decryption process. The receiver receives the ciphertext. He has to divide it into 64-bit blocks. Each block is decrypted separately to get the plaintext blocks. All the plaintext blocks are combined to get the original message. The decryption process uses the same key which is used in encryption process. Now these are the expressions on the decryption. M1 equal to dk of C1, M2 equal to dk of C2 and so on, Mn equal to dk of Cn. Here finally we have to combine all these M1, M2, Mn blocks to get the plaintext message M for the ciphertext C. Now this is CBC, cipher block chaining mode. Here also we have the plaintext M. The plaintext is divided to 64-bit blocks. If necessary, the last block is padded with zeros on the right hand side. Now M1, M2, M3 and so on Mn are all 64-bit plaintext blocks. CBC selects one random number which gets exclusive odd into the first block of the plaintext and transmit it along with the data. This is initial random number is what we known as initialization vector. Now in this diagram we have to observe that M1 undergoes some plus circle operation with IV. This is what we called as initialization vector, which is some random numbers. Now the output is encrypted by using some K to get the C1. This C1 is forwarded to the next round plus circle along with M2. Now again we are getting some 64-bit value that is encrypted by using same key to get C2. This C2 is forwarded to the next round plus circle and so on. And in this way finally we are getting C1, C2 and so on Cn blocks. All these ciphertext blocks are combined together to get the final ciphertext. In CBC, through the same block repeats in the plaintext, it does not cause the repetition in the ciphertext. Now these are the expressions for encryption in CBC. C1 equal to EK of IV plus circle M1. C2 equal to EK C1 plus circle M2, C3 equal to EK C2 plus circle M3 and so on, and finally Cn equal to EK Cn minus 1 plus circle M1. In CBC, through the same block repeats in the plain text, it will not cause the repetition in the ciphertext. This is the CBC decryption process. Here the ciphertext will be broken into 64-bit blocks after receiving, and these blocks are first decrypted by using K, and the output is plus circled with I1 to get M1. Now the C1 is again forwarded to the next round like this. Here first C2 is decrypted by using K to get some result, some value, and that is plus circled along with C1 to get some M2, and so on. This process is repeated in each round, and finally M1, M2, M3 are all the plain text blocks. These are all combined together to get the total plain text. In CBC, through the same block repeats in the plain text, it will not cause the repetition of ciphertext. And it is the CFB, cipher feedback mode. Here first we have to take the 64-bit initialization vector, and this 64-bit initialization vector is encrypted by using some K to get 64 bits, and out of these 64 bits we have to select some K bits and we have to discard the remaining. Now the K bits are forwarded to the plus circle operation along with M1. The M1 is also having K bits, and after the plus circle operation we will get some cipher block, that is what we called as C1. Here we observe that the message is not of 64 bits. Message block M1, M2, M3, these are not of 64 bits, and these are less than 64 bits. Now the C1 is forwarded to the next round. Here the initialization vector 64 bits is forwarded to the next round. Out of those 64 bits we have to left out some K bits from the right hand side, and those K bits are filled with the C1. Now these 64 bits are encrypted by using some K to get again the 64 bits. Out of these again we have to select only K bits, and the remaining will be discarded, and the selected K bits are plus circled with M2, which is also of K bits, to get cipher block C2, and so on. This process will be repeated. Now finally the cipher blocks C1, C2 and so on, Cn are all merged together to get the final ciphertext. And this is the CFB mode decryption. First we have to take the initialization vector of 64 bits, that is decrypted by using some K to get 64 bits, and out of those 64 bits we have to select K bits, and the remaining 64 minus K bits are discarded together, and the selected K bits are exclusive ORed with cipher block 1, which is also of K bits, to get M1 back. And now this M1 will be forwarded to the second round K bits. Again the initialization vector 64, from the initialization vector 64 bits we have to left out some K bits to get 64 minus K bits. The remaining bits are filled with the M1 to get again 64 bits. Those 64 bits are decrypted by using some K to get a 64 bit output, and out of those 64 bits again we have to select some K bits and discard the remaining. The selected K bits are exclusive ORed with C2 to get another K bits. The output is what we called as M2, and so on. This process is repeated, and finally we have to merge M1, M2 and so on Mn to get the final plain text. And now the diagram on the right hand side shows the output feedback mode encryption process. Here also we have to take the initialization vector which contains 64 bits. All the entire 64 bits are encrypted by using some key to get a 64 bit output. Out of those we have to select K bits and discard the remaining. Those selected K bits are plus circled with M1 to get C1. Here the important point is the output of the selected K bits is forwarded to the next round. In the earlier method the C1 bits are forwarded to the next round. Here the input to the plus circle are forwarded to the next round. So finally here also we have to merge C1, C2 and so on Cn to get the ciphertext messages. And this diagram shows a counter mode, and this diagram shows the output feedback mode decryption process. The decryption process is inverse of the encryption process. Now this is the counter mode. Here first of all we have to take the initialization vector which contains 64 bits. That initialization vector is encrypted by using some key to get the outer outputs. From that output we have to select K bits and discard the remaining as usual. and the selected k bits are plus circled with m1 to get the c1. Now here nothing will be forwarded to the next round. Here the initialization vector iv is incremented by 1 to get iv plus 1. Again the second round proceeds. Here nothing will be forwarded from first round to the second round, and this mode is called counter mode encryption. And in this mode also finally we have to collect all the c1, c2 and so on cn cipher blocks to get the final ciphertext. And this diagram shows the counter mode decryption process, which is inverse of the encryption process. Thank you one and all.